Welcome, everyone. It's so great to see you all here. If you'd like to turn on your cameras, that would be great. We are very lucky to have Professor Rodgers from Rutgers University join us today. And he's going to talk about sustainability-related issues. I'll let him introduce himself as far as his research that he's presenting today. Dr. Rodgers is an assistant professor in the supply chain management department of Rutgers Business School, which I have been very lucky to graduate from as well. So, it's wonderful to.
Me too.
Yeah, actually, that's very true, Ruddy. So we have quite a few professors from Rutgers, in part probably because of its geographic proximity, but of course, because also it's such a wonderful place to learn, and it's wonderful to have you join us today, Professor Rodgers. So if you would like to tell us a little more about sort of your background and how you've what inspired you to pursue this line of research, and then to talk to us about your research project, we really love to hear from you. Thank you so much again.
Sure. And thank you for the intro, and thank you guys for having me. Excited to talk to you all today. But just about my background, I'll start there first. So I'm an engineer by degree. So a lot of my engineering colleagues would say that I converted to the dark side and now the business school. But many years before that, I actually worked in supply chain professionally as a practitioner in the pharmaceutical industry. And that was kind of my catalytic moment to go back to graduate school to pursue a PhD. But academically, a lot of my work research-wise has been focused on the electric power grid in terms of how we expand the electric power grid in order to minimize, obviously, costs and minimize emissions, but how do we internalize some of those external health damages from pollutant emissions and things of that nature. So, it's kind of translated into a lot of additional work. I've partnered up with the state of New Jersey, the New Jersey Board of Public Utilities, and building out some of their scenarios for their energy master plan. I've also, with this particular work that I'll share with you, started to venture into sustainability over the last year or so by looking at recycling processes and procedures, both internally at the university and outside of the university. So most of my work looks at using analytics, optimization, simulation type of work to understand processes that are kind of, I guess, stochastic in nature, but also, processes that kind of are supply chain oriented, and also kind of deal with sustainability as well. So that's kind of me in a nutshell. I've been on the faculty at RBS now for about 6 years now, which seems crazy with COVID. I barely know what day it is, but yeah, I'm going up for tenure hopefully in the next year or so. But that's me, and I'm excited to be here and share my research with you all.
Wonderful. Thank you so much. Did you want to pull up your presentation?
Yeah, I can share my screen if that's okay.
That would be great. Thank you.
Yeah, absolutely.
Excuse me. So really, this work, I kind of want to take a step back at the very beginning, talk about how I interpret sustainability in supply chains, and then I'll talk about some of the work that I've done with the state with respect to recycling, particularly its grant-funded work through the university related to single-stream recycling processes. So the way that I think of sustainability, I think one of the most prominent sorts of models, managerial models of sustainable supply chains and business operations, so it's a triple bottom line, right? Financial performance, social performance, and environmental performance, right? Kind of sustainability is kind of the nexus of those three areas in terms of how we grow our companies, how we manage our businesses, provide value to our stakeholders and our shareholders, by being socially, while being socially responsible, treating employees fairly, being engaged in the community, and while also being environmentally conscious as well, not polluting, being net zero, things of that nature. But I think, for all of us here, particularly me, a lot of my work is in operations research. Oftentimes, these three objectives can be competing at nature, right? So to me, this is one of the more interesting models, kind of seeing kind of how companies that do this well are able to strike that balance really, really nicely and uniquely. But to me, this is kind of one of the things that are the three pillars of sustainability, in a sense that things that need to kind of be traded off, if you will. Okay. Oops. Excuse me. Sorry about that. With respect to supply chains, it's obviously end-to-end transparency is critical here. And that's not just for a purely operational perspective. Of course, from your raw materials planning all the way through your demand planning and production activities and distribution activities. It's great to know kind of how each of those organizations are performing. But, sustainability really kind of looks it performs its best when you have that end-to-end visibility, where you can really see kind of where your raw materials are coming from and how you're sourcing those materials. Excuse me, how they're consumed through your process, how your customers then utilize those products, and then creating kind of this home for, kind of, I guess, a circular economy, if you will, and also last mile logistics and things of that nature, right? Product returns. So looking at the overall product life cycle, right, of a product, and also how your supply chain is a big part of that. So really having visibility from your sources to your customers is really key with respect to sustainability. Excuse me, I'm sorry. Allergies have really been bothering me the last couple of days. But I actually, before when you guys reach out to me to give my talk, I obviously wanted to talk about my own research, but it made me kind of come out of the weeds a little bit of my own work and start to think about kind of the broader research themes with respect to sustainability that I've seen in the last 10 years or so, 8 to 10 years. I look back at a bunch of papers. Obviously, environmental sustainability and supply chains is one major theme, right? I mentioned circular economy and economic growth, maybe a sustainability-focused net zero carbon emissions in your supply chain designs, things of this nature, kind of how we can be environmentally conscious, and how that translates even into a global market perspective, right? But the second one to me is really interesting as well. Sustainable supply chain planning and decision making. I kind of created these little pillars myself. Really, kind of how do we build in decision support systems or design decision support systems in supply chains so that we can evaluate or operate with the goal of sustainability along the same criteria as cost and efficiency, et cetera, right? So obviously one of the big areas in this branch of research is multiple objective optimization. So here you have, sustainability objectives, environmental, excuse me, like our environmental considerations, financial considerations, like the triple bottom line, right? How do we, in each supply chain to be very different for different products. So just kind of work in that space. Also, an interesting field is how sustainability kind of enhances competitiveness. So a lot of companies have made it kind of part of their core businesses, part of their core business or core competencies to put at the forefront their sustainability initiatives to attract customers, right? So it's in part by design. And obviously there's trade-offs between, economic and environmental considerations. Those are things that are kind of at the forefront here in that pillar. And the last one is, I call it the social and economic sustainability in supply chains. So, from a managerial perspective, how can we ensure sustainable supply chain practices and in emerging economies, right? So that's a big trade-off here, where in emerging economies and emerging developing countries, right, there often is a focus on satisfying demand at least cost, and expanding the capacity to just be able to compete. and oftentimes sustainability is an afterthought in many instances. So how do we put that up at the forefront? Also, the integration of quality and supply chain management as well, kind of, thinking Lean Six Sigma, but integrating sustainability practices into that. And also, pressures from champions and customers for supply chain sustainability. These are kind of the common themes that I looked at for me that kind of seem to kind of be at the forefront here. Okay, so I'm going to kind of talk about my research that was funded by the NJDEP, New Jersey's Department of Environmental Protection, their Recycling Enhancement Act research grant. So essentially this work looks at single stream recycling processes at Rutgers University. And our goal with this, in short, was to really try to understand these processes and also at the same time come up with new ways, to leverage analytics, leverage simulation methods, to then start to say, okay, these are particular areas within our process that we can mitigate or put in mitigation practices or mitigation tools to then reduce the amount of contamination in our recycling streams. So the research team consisted of myself and two other faculty members at RBS in the supply chain department. Dr. Kevin Lyons, who we all look at Rutgers as our sustainability point person. He kind of, at one point, he was the chief procurement officer as well. So he's a wealth of knowledge. He's been around the university for a long time. And also Dr. Matthew Walsman, who is a faculty member as well in supply chain, but he does a lot of work in sustainability as well. And this kind of seemed like between the three of our skill sets, Matthew Walsman being an empiricist and me being a modeler, and Kevin kind of having his arms everywhere, seemed like a really interesting area for us to collaborate. And along the way, we collaborated with two students as well who supported this research, Shane McKinley and Christopher O. And these two students, Rutgers University, particularly the business school, spans two campuses in New Jersey. There's a Newark campus and a New Brunswick campus, and the faculty is the same in both areas. And it was good for us to have representation from both campuses. So Shane is from the Newark campus and Chris is from the New Brunswick campus, just to kind of get their perspectives on some of these issues. So just a little bit of background about the single stream recycling program at Rutgers. This was implemented in 2011. We used to have multiple streams of recycling, and we kind of consolidated it to a single stream process for us as, I'll call us the end users, right? But the goal was to increase ease and participation in recycling. So we were hoping, at least the university's facilities team was hoping to increase adoption of recycling, right? And this was a campus-wide effort. It was available to all students and faculty in all buildings, academic buildings and residential. But of course, without any, big initiatives like this always encounter challenges. One of the big ones being contamination, which is what we focus on, but also cost increases and communication barriers as well. So, so the contamination issue was one of the biggest ones, biggest motivating factors for us in terms of pursuing this work. But again, let's talk about kind of how, kind of giving more context on these issues and challenges related to single stream recycling. Some of these we've seen before, and a lot of these are related to compliance, right? And students not knowing or really understanding, or faculty members, employees not really understanding what goes where and how this process actually works, right? Not having the end-to-end visibility, as I mentioned. So we've seen a lot of leftover liquids contaminating paper materials, or recyclable materials being bagged in plastic bags, right? That creates manual labor during the sorting process, right? So you got to rip the bag open. Dirty paper products like pizza boxes being put in the recycling bin, things like that, right? But ultimately, those top three items, those contamination issues, increase costs by about 25 to 50% per ton over that period starting from 2011. And of course, there's language barriers, Rutgers, diversity at Rutgers is really important. So you have students from all backgrounds, many different areas of the country and globally. But a lot of the challenges, communication challenges existed, and also making that process very much, I guess, foolproof, if you will, was a challenge, right? A big challenge for us at the university as well is our sports and athletics, particularly during football games, right? Lots of trash is generated during these major events, these sporting events. And of course, that in conjunction with these issues as well, and some of the aforementioned challenges I shared with you, really led us to really hone in on this contamination issue and start to kind of peel the layers back one by one. And we're still kind of working through that, but kind of was our motivation for this. So in response to this, what we've done, we've kind of taken a Lean Six Sigma approach, if you will, kind of the DMAIC methodology, DMAIC approach to find, measure, analyze, improve, and control, for those of you who are Six Sigma green belts or black belts or what have you. But we started kind of, through the define phase, really starting to, and kind of fact-finding phases, kind of working with the key stakeholders and process experts who are part of these processes to really get a good baseline of the current state. That was one of the things kind of going into this, that I don't think anybody at the university, particularly in New Brunswick, where a lot of this work took place, had a full appreciation of the processes. Folks knew their particular roles, but they didn't really know what was occurring upstream or downstream. So that was a really important process for us. Luckily, there was some existing data that we had for our recycling process, but that notwithstanding, we were able to generate a discrete event simulation model that mimicked the single stream recycling process. And then from there, we went a step further to estimate the societal damages from contamination. Now, of course, this is the first step in this process. This was a 1-year research grant, and there are multiple efforts behind this. And we're looking to build out sustainability within RBS, particularly in supply chain management, as a real core competency research-wise. So this is going to be an ongoing effort. But future, we plan to come up with recommendations to reduce contamination. But one of the more powerful things with the discrete event simulation model, which I'll share our methodology with you and more detail about that later on in the talk, is that it allows us to really look at specific areas in the process and really come up with cheap experiments, computer-based experiments that don't utilize resources. And in many ways, we can use this as a way to inform field experiments, if you will. So that's something that we look to do in the future. And obviously, as we come up with these new solutions, updating professional development and training as needed. Rutgers University does a lot of training, recycling training for many companies and many state organizations as well. So, going back and looking at the information that's part of that curriculum and those curricula would be a part of these efforts in the future. But without any further ado, let me talk a little bit more about some of the research findings we found and some of the more things in the weeds here. So what we did, we met with several stakeholders at the very beginning of this, and as I mentioned, created process maps. And again, you'll notice that the process maps here between Newark and New Brunswick campuses, they look kind of similar. But what we've noticed that, Newark campus and New Brunswick campus have different process actors or different partnerships, different relationships as far as how their single stream recycling is being handled. Okay. Also, we took a visit to Colgate Paper Stock's facility, which is a facility in the New Brunswick area in New Jersey, to look at how recycled product is sorted at their facility. It was really cool to see kind of a lot of the equipment and some of the pain points that they encountered as a result of our contaminated recycling product being pushed through their systems. So that was really just kind of eye-opening for us. But taking this kind of process-oriented view of this was really important for us. Documenting this in a swim lane process map was really helpful. One, you can kind of see where each entity or each organization hands off process steps. So you can kind of see the inputs, outputs, and inputs respectively, right? And then there's clear, definitive start and end dates. And as I said before, in these rooms where we were creating these process maps, and we have more detailed ones here. I'm just showing you kind of the mid-level detail. I think, like I said before, it was for a lot of the organizations, particularly for really our internal folks, but also the external collaborators that we work with. It was good for them to see what happens upstream, right? And things that are happening downstream. And I think doing that exercise collaboratively really helped. There were some opportunities that came to light. There's some ideas that came to light during these sessions that really helped us will help inform our future research. So let me talk a little bit about the discrete event simulation model. So again, we use the process maps as our basis for the discrete event simulations. So, and to just kind of as a pilot for these exercises, we focused on the New Brunswick campus for now. And again, we'll extend this out to multiple campuses, multiple regions, et cetera, throughout the university, but focused on three major segments: front load dumpsters, the football stadium roll-off dumpsters, and community roll-off. So this is kind of just, again, proof of concept modeling for us. And the data was based on our full year 2021's data. We have just recently compiled 2022's data in the first quarter, or towards the end of the first quarter of the year. But by the time we started doing our modeling, we only had the full year of 2021. And we built this out in Arena. It is a common discrete event simulation tool. There's other tools that are out there. Arena at Rutgers, we have a lot of expertise there. But that's kind of been our tool of choice here for this particular exercise. So this is kind of a snapshot of what that you see at the top there, how the discrete event simulation model looks in Arena. And of course, the input data is simulated from a distribution, right? So you can get a range of outcomes, which is great. But there really are, at a very high level, three main steps to this process, okay? So the first step, upon, trash being picked up from the particular location, WM Waste Management are one of our vendors. They'll visually inspect the trash and immediately send contaminated material to a landfill. So they'll pick things apart, send it to a landfill. So that's one part. And this is about the amount of material being sent to the landfill at this stage in step one. It's about 1% of the total volume. And again, we simulate that from a normal distribution for the model. Second step, after this stage is completed, all the non-landfill trash goes to Colgate for manual sorting. So the trash is on a conveyor belt, and there's folks literally picking out contaminated material, plastic bags, et cetera, from the recyclable material. So from this, an additional 5% of non-recyclable materials are eliminated. So that contamination is captured. Then at the very end, the final step, there's an automated sorting process, which is actually really remarkable to see. And I should have put in some pictures in here for context. But this is able to really yield an additional 1% of unrecyclable material. The manual sort process is really efficient. So what comes out of this, out of step two, is an additional layer of contamination that's caught. So what I'm showing you here is just kind of we at each stage of the process, how much contamination we're actually able to pick up on average, right? And these are runs from the simulation model. This is a snapshot of 1,000 replications, again, with a CV of 0.1. On average, based on the most recent year's data, got about just under 750 tons of trash every year for those three segments, 740 to be exact. And on average, once we get through the end of the process, contamination is at about just under 12%, 11.4%. So translates to about 85% or 85 tons of recycled material being sent to a landfill. And our first intention when we started this process and started looking into this was trying to figure out ways in which we could, at least immediately, make changes within this process and up front, which we're still working through. But those 85 tons, in our eyes, was very significant every year, multiple years over and over. I'm sure maybe you've heard of this if you haven't, but when you send trash to a landfill, it contributes to greenhouse gases, particularly methane, which I can't remember the most recent estimates off the top of my head, but methane in terms of the greenhouse gases is about 20 times more potent than carbon dioxide. So this is really potent stuff when things are sent to a landfill, starts to decompose, et cetera. So it could really be harmful to humanity, right, and human health, cause a number of health issues. So upon seeing that, we, really decided that it was, important for us to start to investigate kind of what those damages look like from those 85 tons of contaminated materials being sent to the landfill. So to do this, we took the output of our discrete event simulation and studied it in an EPA screening tool. It's called a WARM model. Now, the WARM model is really a truncated air quality model and life cycle analysis model that looks at environmental impacts of waste data. But basically, at each stage of the process, we plugged in our inputs or plugged in the model outputs to the EPA screening tool to get an estimate of essentially how much methane would be generated, and then applied social cost of carbon estimates. We can create basically understand the carbon equivalent. Again, methane is 20 times more potent than carbon, CO2 in the atmosphere. So we applied the EPA social cost of carbon estimates to really understand the economic value of those damages from this recycling process. Now, again, a lot of these, damages require us to make assumptions about the future. So we looked at really 4 different scenarios here. A lot of these are based on the discount rates, but these are informed by economic policy, environmental policy work at the EPA. So these are kind of their own estimates and their own assumptions about the futures, here, so that align with the social cost of carbon estimates. So I'll share some of the results with you in more detail on the next slide here. But essentially, we had a high impact estimate, which is kind of the worst case scenario. And again, this is a point estimate, right? These health damages can have national effects, right? But what we notice is that the higher the discount rate, and this obviously makes sense, the higher the discount rate, the higher the discount rate and reduce the net present value of the economic damages. So you'll see the higher discount rate, 5%, those damages are much smaller, but the high impact estimate really is the worst case there. The 3% is kind of the benchmark, the IWG's central estimate there. That's kind of their standard. That's kind of what the EPA defaults to in terms of making projections out for the future. But again, it kind of gave us an understanding of what the worst case scenario could be with respect to these damages year over year, right, on average. So again, using the model, the simulation model, this is one of the more powerful features of a simulation model. You can kind of study different ranges of outcomes. And you can see that there's the high impact estimate is still the highest, of course, as I increase the contamination levels, really around once you get to about 12.2, 12-ish%, right? You see a big jump from 12 to 13% across all the scenarios, with the exception of the 5%. But there's a noticeable jump between 12 and 13 to 15%, right, in terms of what those damages do. So that was an interesting finding for us, and we're gonna have to look back at that some more, right? But again, obviously, contamination has a negative impact on the recycling process, but also, increases emissions use, waste disposal challenges as well. So, but again, this was an interesting finding as we kind of did our preliminary assessment of this. All right, so obviously there's some additional considerations here. So I think that one of the things we'll look to do is, in the future, is expand this study to include more campuses, more locations. Rutgers University is massive, covers multiple cities, if you will. But across Newark, New Brunswick, and even Camden's campus, the policies and procedures are very different across the three, right? So it'll be interesting to apply some of these models to really study these challenges and get to wrap our heads around the health damages across all the campuses, across all the streams of trash, right? One thing we didn't look at, which we hope to look at in the future, is additional variables, right? So we only looked at contamination and the existing process. We didn't look at any other external variables or even internal variables, but that would be good to look at as well. We'll obviously explore different waste management practices and hope that these investigations start to inform waste management practices at the university. But ultimately for us, this is, like I said, the first step in our department in supply chain, and really kind of taking a systems level perspective on looking at our recycling processes and how it affects health damages. So to me, that was kind of, building out those core competencies from a research perspective and also for the university. We plan on extending this work into also food waste as well in the next cycle, the next year. So that's our, kind of some of the things that came to light as far as things we may want to consider in the future. But of course, there are some lessons learned here. Obviously, the sorting mechanisms are really powerful, right? Kind of the manual sorting and the automated sorting processes can really be powerful. But as I said before, really collaborating with those stakeholders was a critical part in this. The process mapping activity, while it may seem kind of simple, to me was the most important part of all this work, because it kind of got everybody who was involved in the process to see what happens end to end, right? And not just your role in the process. So to me, as evidenced by the skill sets on our team, it's good to have a multidisciplinary collaborative approach, because having the modeling aspects was great, but if I didn't have my other two colleagues with us working with us on this project, it would have been a nice model, but I wouldn't be able to account fully for some of the other things that are relevant to this process. So, but ultimately, we think that down the road, these learnings will be valuable for other institutions as we plan to expand our research. So, and also for state institutions as well. So obviously we have some extensions. So in the short term, we'll basically look at our peer institutions in the Big Ten, kind of see what they're doing, and also locally, kind of benchmark ourselves against them, and really analyze our recycling habits and hopefully develop targeted campaigns to reduce contamination. So one of the things that we were kicking around the idea of as we were coming towards the end of our grant was a recycling challenge where we work with the different dorms on campus to create a recycling challenge where we engage the students, and at the end of, let's say, the academic year, you have some sort of incentive for the students outside of their product, outside of their I guess bragging rights. There's some sort of benefit for them. So, but of course, from these learnings, obviously have to do some more digging, but piloting some test solutions, and really doing a deeper dive into some of the environmental impacts as well, and updating the training. But down the road, educational outreach activities for sustainable waste management, policy challenges. We have at Rutgers University, we have the Rutgers Energy and Climate Institutes, so where they've been really helpful in terms of collaborating and really bridging the gap between Rutgers and the outside world on this front. So there's some opportunity there, and really just kind of assess, include potentially stakeholder surveys, waste audits, things of that nature that are more strategic in nature. But a lot of these long-term activities will require buy-in from the university. So there is some additional work that we'd have to think about there. So, but again, this is kind of our first step in the process in terms of building out sustainability as our core competency at the university, but at the same time, helping the university be kind of satisfy that triple bottom line, right, as well. So yeah, thank you for your time. I appreciate you all listening to me. And, as I said before, I'm happy to take questions, and I'm excited to be here and engage with you all. So thank you. I guess I'll stop sharing here, kind of put myself back up here.
It looks like Professor Peavy has a question.
Sure.
Thank you so much, Dr. Rodgers, for such an amazing presentation. This is completely outside of my area of research, but it's so interesting to learn about all the wonderful things we can do for the environment, and all the opportunities we have and what we're not doing. So thank you.
Thank you. Thank you.
Peavy?
Yeah. Thank you very much. This is really amazing. And what I really liked is the multi-pronged approach to the problem, right? I mean, we are all in our own silos, we think very narrowly, and this is like amazing. But having said that, I'm going to ask a narrow question.
Sure.
Which is the discount rate. I mean, I'm sorry, I teach finance, so I naturally think in terms of discount rates. But the discount rates that we usually use come from financial markets, etc. It seems to me that is not completely inappropriate here, because you want a societal discount rate. So I was wondering where you came up with, some guidance. As I know you use a variety of them, but it seems like you fixed on 3 a little bit. So how did you come?
Yeah, so that's a good point you make. I mean, this has kind of been a bigger question when I've done work on the electric power grid, right? Where we're making capital investments and we're kind of leveraging public sector funds and private sector funds. How do we choose the discount rate? Because it's going to be a difficult subject. For this, since we were just trying to really understand this, we used the scenarios were actually developed by the EPA in terms of projections for the social cost of carbon. So we just adopted them, just basically married them with our discrete event simulation model. So we just kind of took it at face value. But like I said, there's lots of work that we need to do. This is kind of our first step in this process, right? But I think getting a sense as to what those damages look like, and I think this is a nice step in the direction of kind of constrained optimization. Once you can quantify those costs and those factors that influence that cost, depending if you're looking at a short-term problem or a strategic problem that takes multiple years, you can then minimize societal damages, right? Come up with a plan that puts those in the forefront of that objective. So, but to answer your point, I had to go back and look at those EPA sources and maybe connect with some of the folks at the EPA to kind of see why they chose those discount rates. But we just use what their resources, their inputs were for the time being.
Thank you.
It's a good question though. I see Jordan has a hand raised and Chantel.
Yeah, so first of all, Professor Rodgers, thank you for the case study and the lecture. Definitely really informative, and appreciate you walking us through it. Being that currently in Professor Dutta's data analytics class, I'm curious to know what analytical tools in Excel you use to reach some of this information. It looks like some of the feedback was presented in a Gantt chart from a critical path kind of project management sense, but in terms of the analytics side of the data, was wondering if you'd be able to speak to which formulas or processes you use to get there.
Got it. So it's a good question. So a lot of the data that we got from the university stakeholders was from Excel. So it just was kind of input data that we just kind of summarized to align with our process. Some of the data we got from our stakeholders was verbal data from interviews and things like that that we had to try to deal with. But as far as the analytics, kind of the engine of this, discrete event simulation, it runs based on probability. The tool that we use is called Arena. Arena basically can take a process map, and depending on the metrics you're interested in, each process step, you can layer in cycle time and output and throughput, et cetera, and you can simulate them from a distribution. So basically, the big one that we simulated through was actually tonnage through each process step, and also contamination, right? Different realizations of that. So we simulated those from a normal distribution with the CV of 0.1. Arena actually is really great because once you push the button, it basically runs an experiment with a scenario extracted from a realization from a normal distribution. So you get different values across the chain. So it's governed by probability, but Arena actually does a lot of the work behind the scenes, conditional probability stuff. So there was nothing that we had to do by hand, no programming. I think Arena that's one of the benefits of Arena. Its user interface, is really friendly. You don't have to write any code, so which is nice. But it actually, running from code wasn't the issue here. It was the right tool for the right application. So that's kind of, to answer your question, Arena is the tool for discrete event simulation that we use to get the outputs.
Awesome. That's really helpful. Thank you. And then the other thing that I was curious on, it seems like when you're determining the contamination levels, it almost seems like a margin of error, so to speak. Is there a way that you're determining that range in terms of the contamination you're expecting and how to factor that in when building models?
Right. So this is one of the benefits of discrete event simulation. So we were able to run hundreds of thousands of replications of this. I only showed you 1,000 just to kind of, so then the graphs didn't look ridiculous, but showing, I can run many replications in a matter of seconds. So that was a benefit to us, which is why we were able to get a range of outcomes, because the model basically was able to run through a range of different scenarios, which gave us different outputs. So we study those outputs in the WARM tool, which was really nice for us. So that's how we were able to get the box and whisker charts, those box plots for each of the different cases, and also the cost as well. So.
Gotcha. Yeah, definitely really helpful to know, and really appreciate it. Thank you.
Great, sure.
So I am not as thorough as my classmate with respect to data analytics. I'm going to go with what I know and what I like. I most recently served at Pace University doing their public affairs, government community relations. So I was wondering, do you see any, I hear the EPA, that's a federal scope, right? So I was wondering if you see any state and local application to what you've done on the campus, or are you all keeping an ear to research that is similar to what you've implemented on campus?
Right. So this research was actually funded by the Department of Environment, the State Department of Environmental Protection, NJDEP. So we hadn't worked with them in the past at RBS. At Rutgers, we've worked with everybody. It's a huge place, but RBS hadn't worked with the state in that capacity with DEP. So this is kind of the first relationship we've built with them. And we hope to continue that with them, because I think that there are some applications within the state. And I think this has really informed the proposal. I mean, the RFP that went out for this grant was really informed by some of the challenges, at least we think some of the challenges at the state level in terms of single stream recycling. So there were several other topics, but it kind of happened to be right place, right time, because we were starting to kind of think about single stream recycling, and the call went out right around that time. So on the federal level, I mean, we work with the EPA. We haven't kind of done, at least we haven't done the work to kind of build that relationship on that front. Other departments, other schools at Rutgers have really strong relationships with the EPA and the Department of Energy, et cetera. And I've worked with the Department of Energy as well. But right now, for this particular effort, it's been state focused at the moment. So
Thank you for that clarification. And did the grant have, was it a broad grant or was it a higher education institution grant?
it was broad. So it was open to public sector, private sector, universities. It was pretty broad. So,
well, that's interesting because I'm suspecting that since college campuses are kind of a microcosm, how that might be applicable to the statewide college and university system, or there's the implications could be.
Yeah. So I do know that there's going to be, we haven't seen I haven't seen all the work that was funded under this RFP. So I know some of the grants that were funded were very much townships looking to implement a solution, a recycling solution, where it's very much consultative in nature, right? Mm-hmm. But this was very much resource oriented. So I'd be curious to see kind of what the state has done on that front, kind of where these efforts have led. And I know that there's multiple rounds of this. Every year, this will be an annual thing now. So it's cool to kind of see how that will, from the state's perspective, how they view this and where this will go in their eyes. So yeah, it's a good question.
Yeah, I'm sure there would be data analytics that came out of that, but in New York City, they're actually piloting the Department of Sanitation is piloting in Harlem a containerization pilot program to really help with the rodent issue and see, as far as optics, how does it look? So I'm interested, this all kind of aligns.
Gotcha. Cool to see. I think I see another hand raised. It's like Janice has a hand raised.
Oh, hello. Hi, Mark. Thank you so much for the talk. Nice to hear from a fellow Rutgers graduate. I got my PhD from Rutgers many years ago in operations research. Cool. And I was curious. So you mentioned a constrained optimization. So were you thinking of maybe getting using the output from your simulation to formulate like the constraints in the some kind of optimization model?
So to put this in, that's a good question, Janice. So to put this in perspective, I'll kind of share with you what we did for the electric power grid work. So essentially, a lot of problems that are, related to capital investments and strategy look out over a certain time horizon, and they seek to minimize costs subject to some decisions or some constraints, excuse me. So for the grid, it was what types of power plants do you invest in, and where do you make those investments, and how much of the electricity do you use, right? Things of that nature. And there's capacity constraints, there's supply and demand constraints, all that stuff. But for the challenge there was, we did similar work where we embedded the health damages, and we had a similar model. It was an OR model that linked to an EPA screening tool that gave us estimates of the damages. We were able to take those damages and stick them in the objective function. So instead of minimizing just market costs, we also minimized the health damages. So that really changed the way, from a decision maker's perspective, kind of what the incentives are, right? And kind of how you view the problem. So we saw a lot of really interesting things from the grid perspective, but this work that we're doing here in the recycling process be similar in some ways. I kind of mentioned the constraint optimization stuff. It's really hard to kind of wrap your head around some of those external costs, because if you're the decision maker at the university, you might be aware of them, but you might not have a handle as to the scope and the magnitude of them, where they're coming from, what decisions influence them. And we still have a ways to go, as I mentioned, some, really studying the other variables in the problem and how that would influence the health damages here. But, if we were to implement a particular set of policies or a plan for the future, instead of minimizing it at least cost, we can now have a full picture of total societal damages and really see, kind of try to really strike that balance. Like I said, that true bottom line, right? Viewing all the costs on the same scale and using it to drive the decision. So that's kind of where I was headed with it. We have a long way to go with that. But at least I think it's a step in that direction. All right.
Okay, great, thank you.
Sure.
Does anyone have any other questions? Oh, it looks like Preetha does. Go
Nice
ahead.
and
Hi. So, first of all, I'm one of those people who don't know exactly where to put items when trashing them. So the single stream recycling just makes so much sense in terms of reducing barriers to recycling. So,
right.
and I was thinking, like you mentioned, like extending this to food, and I was also thinking healthcare, right? Like on campus, we have healthcare facilities. That would be another like massive challenge because you're looking at hazardous materials and what I wanted to ask you is that, in terms of optimization, we always think of capacity constraints, right? So when you were coming up with the process map, were there any, like, again, I mean, it's a different approach, but are there any capacity constraints in terms of recycling and waste management on campus?
So there are, we didn't explicitly consider them as part of this effort, but the manual sort process has physical capacity constraints. The automated sorting process has physical capacity constraints, and also waste management. The truck drivers that come and pick up the trash, they're on a route schedule. So that's another capacity, a physical limitation. But all of the constraints are outside of the purview of Rutgers University. We can't really control how those other entities operate, but that doesn't mean that they're not important, right? So I think it's important for us to, as I said, those other variables are really key, right? But I think this kind of speaks to where Rutgers University can start to have those informed conversations with its stakeholders and say, well, how are we really operating? What do we, I think we're trying to like really obviously minimize the contamination, but also at the same time, kind of understand how this thing works. I think from a operational perspective, we found it's kind of like a black box. It's like, okay, this is our supplier and this is the relationship we have with them and they handle it, right? So it's handed off, it's subcontracted in that way. But I think having more visibility into and kind of the nuts and bolts of the operations would be helpful in terms of managing the expectations of the outcome. So.
And, again, like it's interesting to see that whether it's a campus-wide effort or a supply chain, in a way, a process, or whether it's a global supply chain, right? Visibility and communication between stakeholders just is so important. So,
Absolutely.
Thank you for pointing that out. That was my question and comment.
Sure.
Thank you.
Yeah. I think we got Jordan back here again too.
Yeah, sorry, just one more question following Professor Dota's question, because I'm curious to know how you kind of determine the likelihood of these models and evaluating them in comparison to those external factors, like the uncontrollables that you mentioned, and how those play into the accuracy of the models that you build when testing these types of programs.
Right. So we basically, how do I say this? So the process mapping effort was our first approach to trying to understand, one, how the process works, but also the variables that were within the scope of this. Okay. So now there's lots of other variables. I think a big one is student behavior that we did not consider at all. And that's a big one. And I think for us, and I've worked with some folks in our public policy school who've used agent-based simulation, where they try to kind of model human behavior and the dynamics of that, and different outcomes of that, kind of how that would weigh into this. But, probabilistically, using a range of outcomes kind of accounts for the range of uncertainty. So, not every variable was considered explicitly. It was really just kind of the 3 contamination variables, at least that we would share with you, and the throughputs. And that was what was within our scope. And we started intentionally with a very small problem that didn't have a lot of variables, since it was kind of our first foray into this. But if we were to extend this campus wide, then we would have to obviously expand the number of steps, number of variables into this as well. So we started intentionally small, just to kind of build that out and see if we could actually do it, and actually understand the process as currently constructed for that current scope. But again, it was governed by the process mapping experts and led by the facilities folks and our subcontractors, if you will.
Yeah, no, that definitely makes sense. And I appreciate the added color on that.
I think PV, you got another question for me.
Yeah, figured, I don't get the
That's
opportunity to hear something like this too often.
Sure.
So, I understand the use of arena. I mean, I don't know arena itself, but I understand that kind of simulation. But it seems to me that a big shortcoming of those models is that you have to basically assume that all the processes are exogenous. And in fact, you pointed out just now, I was thinking, formulated my question, you were talking about you hadn't taken into account student reactions. But
Right.
the way you're addressing even student reaction, you're thinking about it also seems to be as something exogenous, because you said, we'll use a range of parameters, which again suggests, there is something that can be taken as exogenous. We don't know what it is, therefore we are going to use a range. But it seems to me, some of many of these individuals are also, or entities are also maximizing entities. And particularly, when you have, maybe students, they're small enough and maybe they have, there's a variety of objective function that they have, and maybe they don't, they satisfy. So maybe you can get away with treating them as exogenous. But I'm wondering, if you have larger entities, this might not be particularly relevant if you're talking about the campus, but if you're talking about waste generation in a larger environment, you have companies, etc., which you refer to obliquely in the beginning in the broader area of supply chain research, and these entities are playing a game. I mean, I don't mean in a technical sense, right?
Yes,
So, I mean, that requires real modeling, and, particularly when you come up with new solutions, without that modeling, you might end up making a prediction and it could be completely wrong. So, have you come across with these kinds of things in your current project? And, where do you see how these things play out?
So that's a really interesting point. So in this work, like I said, this is our first foray into the recycling stuff. So none of us really have much of a background in that area. So, but I see your point. I think a lot of my research in that space kind of, or at least my touch points to your points in that space kind of come from my work in the power grid, where you have different entities and they all have their own objective that they're looking to maximize or minimize. And then the grid has its objective, right? So I've seen that in the past, but they're usually larger entities that have an objective at stake there. But yeah, there is, each problem like that is very different, right? And I think, looking at each of the entities' objective functions and determining if you can reasonably endogenize those into the model include them into the model instead of making an exogenous say, oh, I'm just going to simulate from a distribution and account for all the uncertainty. It's good to know where the uncertainty comes from so that you can adequately represent the system. And ultimately, when we build a model, it allows, you want it to mimic reality as close as you can get to that. And of course, along the way, that requires you to make assumptions and things of that nature. You will do that. That's kind of one of the drawbacks. But the way that we were viewing the model is kind of as a starting point. In the future, we have an empiricist on the team, and he's a controlled experiments guy. So the model would kind of be a way of one of the ways that would inform the types of experiments we would run on campus with the students and with the administrators, et cetera. So I think it's, like I said, this is the first step in that process, right? And we made the models intentionally small, but at the same time, it really kind of is a cheap way of getting some insights that are reasonable. And I think, this is kind of, many years ago, I was a management consultant, right? So, the model, it's great to build models, but at the same time, we have to understand that there's a purpose for them, right? We want to try to make the right decisions. The models don't solve everything for us, and we can mimic reality as best as we can. But at the same time, we got to come up for air and say, okay, what are we truly trying to solve for here? The models can help us get there, but there's got to be some other tools. There may be some other tools that we can leverage along the way. So that's kind of why we took that multifaceted approach where we have folks with different backgrounds on the team, because we each have our own core competencies, but I think together we can find a nice home and come up with some innovative solutions. But to your point, yeah, it's a really challenging problem, especially when you have entities that have their own objectives, right? To build it into a single model, it's very tough to endogenize all those things. So we treated it as exogenous factors, true uncertainty that affect the parameters. But if we had better visibility into some of those variables, we can endogenize those and include that.
Thank you.
Yeah.
Well, thank you so much. We are out of time, and it sounds like lots of questions are still there, but we really appreciate you sharing your research, and it's been such an amazing presentation for many of us who are from different disciplines, but just very interesting to learn about your sustainability research. And thank you once again.
Thank you for having me. It was great to be with you guys. And yeah, we'll be in touch.